Hello, good evening all.
Good evening, ma'am.
Welcome to the last day of the session. Today we will be studying about two planets and a satellite. We'll be discussing about Uranus and Neptune, and also we'll have a PPT on moon's phases. Also, I'll give you some tips to how to attend the exams in which place you can see the slide. So Uranus. Uranus is the seventh planet from the Sun and the third largest planet in the solar system. Also, Uranus is one of the four gas giants in the solar system as well as one of the Jovian planets. It's also called the twin planet of Neptune. In the coming slide, we will see why Uranus is called the twin planet of Neptune. And these are some of the facts about Uranus. So, who discovered it? It was Sir William Herschel, and he became famous for his discovery of the planet Uranus, along with two of its major moons, Titania and Oberon. He first recorded the discovery of a faint object that might be a nebulous star or maybe a comet, and later he understood that it is a planet. Now, how did Uranus get its name? Uranus is named after the ancient Greek god of the sky, Uranus. He is the Greek god of the sky. Why? It could be due to this bluish tinted color. It got the name of the sky god. Before that, there was a number of names proposed for Uranus. Herschel wanted it to call as Georgium Sidus, and then some named it George's Third's Neptune and Great Britain's Neptune, etc. Then some suggested Hypercronius and Trans-Saturnus. Now the name Minerva was also proposed. Finally, the editor of Berliner Astronomical Laboratory opted for Uranus. Everybody, please mute your systems. Okay. Now the symbol of Uranus. This is the symbol of Uranus. It is derived from a combination of Mars and Sun symbols. The H from the system is taken, from Gustav last Herschel. Also, now let's talk about the size of Uranus. The diameter of Uranus is 51,118 kilometers. And the total volume is 6.8 into 10 raised to 30 kilometers. Now, mass is in the range of 10 to the power 25 kilograms. So see, this is Uranus' internal structure and this is Neptune's internal structure. Look at the similarity. This is because why we call these planets twin sisters. Now, look at the core of Uranus and Neptune. It is actually a rocky core. It can have even more than the size of Earth. And there is a mantle above the core. It's highly compressed liquid water and ammonia. And this is molten, this is liquid state. And there is liquid hydrogen and helium in the atmosphere, the surface layers. And above that, there is an atmosphere. There is an atmosphere. So these are the three layers of both Uranus and Neptune. It has a rocky core in the center, an icy mantle surrounding that, and an outer gas envelope of hydrogen and helium. Look at the atmosphere of Uranus. It's composed mainly of molecular hydrogen and helium. The third most abundant molecule after the hydrogen and helium is methane. So the atmosphere is made of hydrogen, helium, and methane. And now, this slide, you can see the tilt of 98 degrees. It It is a maximum tilt by any other planet in the solar system. Neptune has a tilt of 30 degrees. And see here, Earth has 23.5. Jupiter only has 3-degree tilt. Saturn has comparable to Earth, that is 27 degrees. But Uranus, see, 98 degrees. So there are many hypotheses regarding how this tilt came. One of the example is of, you know, some larger body might have hit Uranus that might have made this tilt. So it's also called rolling planet. Rather than orbiting, it's like rolling a
So,
ball.
Miss, it goes like down to up.
Yes, yes, yes. And this is the gravity of the Uranus explained in the slide. The gravity of Uranus is 0.89 or 89 percentage of Earth. And the temperature, the average temperature of the cloud tops Uranus is minus 53 degrees Celsius, or up to the minimum temperature which is possible, the 0 Kelvin temperature at least. Up to that it can reach. And then temperature inside it actually is very hot. It reaches up to 4,727 degrees Celsius, almost 5,000 degrees Celsius. And you know that temperature in photosphere is 5,800 Kelvin, right? Just like Jupiter or any
You're going
other.
to break my food more. I'm pretty sure I can't eat any of this, right?
The weather on Uranus is actually, windy, just like Jupiter or the any Jovian planet. A thick tempestuous atmosphere with winds blowing at a clip of 900 kilometers per hour. And a day on Uranus is 17 hours, 14 minutes, and 24 seconds. So it revolves, it rotates faster. See, this is how from up to down, up to down. This is how it rotates. Now, the 1 year in Uranus, which is 84.3 years to complete its orbit around the Sun. So Uranus takes 84.3 years to complete its orbit around the Sun. Now the distance from the Sun Uranus' distance from the Sun is 2.88 billion kilometers. Uranus is located at 2.88 billion kilometers from the Sun. So the orbit of Uranus, you can see the orbit of Jupiter, Saturn, Uranus, Neptune, and also you can see, the orbit which is out of the plane, this long elliptical one, that is Pluto's. And inside that, here you can see the uh, orbit of Neptune, and even inside that you can see orbit of Uranus. Uranus doesn't have a perfectly circular orbit. Instead, it follows an elliptical path around the Sun.
Miss, if you
Yes.
see the orbits of Pluto, Uranus, and Neptune, they kind of meet at a point. So, what if they both collide?
There is a good. It's like it's in the different planes. Okay, there are only 2-3 points where it is
Yes, Miss.
intersected,
Miss, that's
and
right. Because it takes years for all of them to rotate, so it is rare that they'll collide. But still, there is like a small
Yes, that is true. There is a good chance of it to collide, but yeah, not till now such collisions hasn't have not happened. But in the future, we are not sure. It may happen, it may not happen. The chances are really less because these are low, very large space we are talking about. So need not to be coming in the perfect time at perfect moment. It's not you know need like
Yes,
it's rare
Roshan.
actually. Yeah. Very good. Now let's move to the next slide. Yeah. Uranus, moons, and rings. Uranus has at least 27 moons. The moons are all made of ice and rock. Most of these moons appear to be captured asteroids due to their size and orbit. These are the names of the Uranus moons: Miranda, Ariel, Umbriel. You have to tell me if there is any, peculiarity in these names. If you have heard these names anywhere else, Umbriel, Titania,
Ma'am,
Oberon. Yes.
ma'am, do we have to remember these two complete tables?
No. You don't have to remember. You just have to see some of the larger moons like Miranda, Ariel, Umbriel, Titania.
Ma'am,
Yes.
ma'am, these moons are named after characters from the works of William Shakespeare.
Very good. Yes, that is right.
Ma'am, Miranda is also name of a code.
Okay. So these names are, the taken from the plays and works of William Shakespeare. That's right.
Ma'am,
Cordelia, Ophelia.
what
Yes,
UV and what we have written UV, UVI.
that is the name. They do have some other names also because these are just common names, right? Other than that, in different, you say, you know, when any object is elliptical object is found, they'll give a name according to which year it is found and where it is found, etc.
Yes.
Okay. Now, yeah. Now, rings of Uranus. The rings were discovered from the Earth in 1977. Some data suggested that Uranus was surrounded by at least 5 rings. Later, 4 more rings were suggested. Now, in the Voyager 2 experiment, 2 more additional ones were found. Now, the exploration to Uranus, let's see. Now, Voyager 2 made its closest approach to Uranus on January 24, 1986, coming within 81,500 kilometers of the planet's cloud top. Now, there are a number of, number of phenomenon and processes in Uranus has been found till then using Voyager 2. One of it is the presence of the magnetic field presence was unknown until Voyager's arrival. But the intensity is comparable to that of Earth. But unlike Earth we know that its intensity, of course, it varies, but the center of this magnetic field is in the center of Earth itself, right? And the magnetic poles are near to the geographical poles. But it's not like that for Uranus because how the magnetic field is produced in Uranus, because we already said that the mantle consists of liquid and molten state materials, right? But it is not everywhere. And this, you know, it could have been not to the center, but somehow in the intermediate space. Not in the center, maybe near to some other areas. Okay, maybe near to the equator also. So this peculiar orientation of the magnetic field suggests that the field is generated at an intermediate depth in the interior where the pressure is high enough for water to become electrically conductive. And Voyager 2 also found that one of the most striking influence of the sideways position of the planet is its effects on the tails of magnetic field. It also found that Its only spacecraft to visit Uranus imaged a blunt-looking sphere in 1986. When Voyager flew by, the south pole of Uranus pointed almost directly at the Sun because Uranus was near its southern summer solstice, with the southern hemisphere bathed in continuous sunlight and the northern hemisphere radiating heat into the blackness of space. Yes, so this is the Voyager slide. We will jump to the next slide, which is of Neptune. Now let's talk about Neptune. Neptune is called the other blue planet. Why? Earth is called the blue planet because of the presence of water in it. But the blue color is not only for Earth but also for Neptune.
Ma'am, Venus color. Uranus color, ma'am.
Oh, Uranus, it's actually, yeah, somewhat blue, just like the sky.
Okay.
Like blue greenish color. It's because it has methane in its atmosphere.
Okay, ma'am.
Okay.
You're talking about Uranus.
Sorry. No, now somebody asked
About color.
yeah, about color. Color of Uranus is blue green. Neptune it is bluish.
Just
Okay.
because of methane.
Yeah. Now about Neptune. Neptune is one of the four gas giants in our solar system, as well as being one of the four Jovian planets. As a gas giant, Neptune has no solid surface. So even if a spaceship could reach it, it could not land because it would simply keep sinking to the planet. And Neptune cannot be seen with the naked eye, and it was therefore not discovered until 1846. It was not discovered until 1846. Now, although Neptune is a gas giant, it is actually a subclass of gas giants known as ice giants. A high percentage of ices in its atmosphere. Next, history of yeah, we went about that. History of Neptune. These are the discoverers. Two of them are there independently they found. Britain's George Couch Adams and France Urban Le Verrier. So there is this question: Who did discovered it? Who discovered it? Britain's John Couch Adams or Urban Le Verrier from France? Actually, both of them were working out the position of the hypothetical eighth planet independently from each other. One was working from Britain and one was from France. And both had a difficult time convincing their colleagues to spend any time actually looking where they suggested the planet might be. So people were not at all cooperating at that time. Later, their colleagues I'm speaking about, and later there is this Berlin Observatory astronomer who was Johann Gottfried Galle. Johann Gottfried Galle used the calculations by Leverrier to find Neptune within 1 degree of its predicted location and just 12 degrees of Adams. Next comes the question, how did Neptune get its name? It was named after the Roman god of mythology. In Roman mythology, a Roman god of the sea. In Greek mythology, he is called Poseidon. Shortly after the discovery, Neptune was only referred to as the planet exterior to Uranus or as Le Verrier's planet. Now, the first suggestion for a name came from John Gale, who proposed the name Janus. John Gale is a person who actually was a Berlin astronomer who actually for the first time saw it, but it was Urban Le Verrier and you know And there was one more person, right? Britain's, yeah, this person, Britain's
John Adams.
John Coach Adams, yeah. So since Leverrier was the founder, because it was with Leverrier's position just 1 degree apart, they found it, and so they named it Neptune. Urban Leverrier, who discovered the planet, claimed the right to name his discovery Neptune. One another proposal was Oceanus. Anyway, it is Neptune. Now the symbol of Neptune, it is a trident. This gold Neptune has a trident in his hand. So he's the protector, a god of the sea. Sea has blue color, right? That's why it's called the blue planet. So three-pronged fork. This is the symbol of Neptune. Now let's talk about the characteristics of Neptune. It has a diameter of about 49,500 kilometers and a polar radius of 24,341 kilometers.
Ma'am, what is polar radius?
Polar radius means pole to pole radius. Like since it is having a you know spheroid, oblate spheroid shape, its diameter means from in the equator level, the pole diameter, but polar radius means from center to the pole.
Okay.
That is 24,341 kilometers. Now Neptune is 3.9 times bigger than that of Earth. In the previous slide, we saw that what is Neptune made of? Yes, this is the core made of rock and ice, and above that there is mantle with water, ammonia, methane, ices. Then there is this atmosphere of Mars, which is hydrogen, helium, and methane gas, and there is cloud tops. See about the upper atmosphere, this image shows bands of sunlit cirrus-like clouds in Neptune's northern hemisphere. These clouds cast shadows on the blue cloud deck 35 miles below. The white streaky clouds are from 48 to 160 kilometers wide and extend for thousands of miles. It's seen at the top of the atmosphere. Now about Neptune's atmosphere, 70% of the atmosphere is hydrogen, 19% helium, and 1% methane. It is the methane which makes the blue color of Neptune. So let's talk about Neptune's mantle, right? So Neptune's mantle is a superheated liquid region where the temperature can reach up to 2000 Kelvin to 5000 Kelvin. So it's very hot region. It consists of water, ammonia, methane, and other compounds. This is Neptune's core we are talking about. The core of Neptune is made of iron, nickel, and other silicates that make up about 1.2 times the mass of the Earth. So this is the gravity of Neptune, which is almost 1.14 times the gravity on Earth. Neptune has a tilt on its rotational axis, which is 28.32 degrees compared to the Earth's tilt. Comparable, right? Only 23.5 degrees Celsius for Earth. Now, at its surface, where the clouds of the planet touch space, the temperature of Neptune can dip down to 55 up to minus 218 degrees Celsius. So in the top of the clouds, it is very less temperature, while as it goes inside, temperature can rise. So the average temperature of the Neptune is considered to be minus 200 degrees Celsius, while the temperature of the core of Neptune is 7,000 degrees Celsius, even more than that of the photosphere of Sun itself.
Is made up of ice and rock, so how that ice can exist at 7,000 degrees?
Yeah, that is a good question actually. See, when we talk about ice and formation of ice, etc., we consider only temperature, right?
Yes, ma'am.
But physics can do wonders. Sometimes even though temperature is high, the
Oh,
pressure
yes, ma'am.
is very
Pressure,
much.
pressure, yes.
Yeah. So this is the climate of Neptune we are talking about, and just like we have a great red spot in Jupiter's surface, here we do have a great dark spot in Neptune's surface. So like Jupiter, Saturn and Neptune, like Jupiter and Saturn, Neptune has an internal heat source which radiates more energy than the energy Neptune is receiving from the sun. When we were studying about Jupiter and Saturn, we went through this concept that although these planets are far away from the sun, they are receiving a low, uh, since they are far away from the sun, they are receiving less amount of sunlight, right? But still, they are giving out more heat to the space, interplanetary space. Why is that? It's because there are internal reactions and interactions happening. That's why. But this causes surface wind to reach extremely high speeds. So this great dark spot, just like Jupiter's red spot, it is a storm, a big storm. So these many of the winds interfere with one another, causing small storms or large storms. This great dark spot is such a storm.
Ma'am, why it is called dark spot?
Because in the blue planet, it is seen a little bit darker, right?
Yes, yes.
That's right. It's very dark and about 1/3 the size of Jupiter's great red spot. And it moves west and winds around it can be measured blowing up to consider this 2,400 kilometer per hour, the fastest winds in the solar system. So which is the
Miss?
fast? Yes.
So the dark spot is like at least as big as the Earth, right?
Yeah. Yes. Yes. Yes.
Excuse me, ma'am.
Yes. Oh.
Ma'am, how does dark spot occur?
Okay, Tushar, please, can you please mute the system? Echo are coming from there. Almost damaged my ear. Okay, so how these dark spots are created? That's why we were talking about it. There are winds um, in these Jovian planets, just like the red spot is there, because since these are continuously, very hot system inside and very cool system outside, and inside many interactions are happening. So some of these, reactions can proceed to a small storms and also sometimes larger storms. So such a big storm of having its velocity of the particles by which it's moving 2,400 kilometer per hour. So it formed a storm. That's why it looks different in color.
Excuse me, ma'am.
All questions can be asked after the end of the session. Is that fine? Please write down your questions.
Ma'am, why these dark spots are not occurring in all planets?
Did I say that questions can be asked in the last of this session?
Okay, ma'am.
How long is a day on Jupiter before that? Yeah. Actually, it is a possibility. Sometimes it can happen, sometimes it may not be happening. And after maybe some few decades, this dark spot may be absent there. Sometimes, it can occur in some other planets. It's just like, why do rain occur? Why do that kind of, you have to think a little bit bigger. Like, since in universe and solar system, nothing happens for unnecessarily, right? There are many processes which are underlying in that. For example, in the dark spot, we said that this kind of storm is present there. Just like that, if there is any storm present in any part of that particular planet or any other planet, it could have been there. But since it is not there, we can't see it. But the Jupiter's red spot is an example of that. And also, if it is small scale phenomena, we won't see it using this. If the planet is really big, right? Since it is a large scale phenomena, we saw it. I think you got your answer. And further, the questions can be asked at the end of the session, please. And a day on Neptune is 16 hours, 6 minutes, and 36 seconds. Neptune's equatorial zone takes about 18 hours to complete a rotation. And the polar regions can take just 12 hours to rotate, much more quickly than the average.
And why this happens? How it can possible?
Oh my god, see, please, everybody, please mute your systems. You can ask the question after the end of the sessions. Please cooperate with me. You're senior kids, right? Even juniors acted very well. So this will be the last question I'll be answering within the session, okay? What is the question again?
Ma'am, I asked that how it is possible, like the equatorial region will means there is differential rotation.
Did I talked about in the sun's PPT? When we were talking about Sun, Jupiter, Saturn, we talked about the same thing, right? Because it is gaseous. Since it is gaseous, different parts of it is rotating in different speed. Because only a rigid body can rotate, in same speed. Every point will be rotating in same speed.
Okay.
It only happens in rigid bodies. These are gaseous bodies. Okay, further questions, please ask at the end of the session. Neptune is approximately 4.4 billion kilometers away from the Sun. And Neptune's distance from the Sun is 4.5 billion kilometers. More specifically, it is 4.5 into 10 raised to 9 kilometers. So this is Neptune.
So how many astronomical units on an average?
Neptune follows an elliptical path around the Sun, varying its distance to the Sun at different points along its orbit. Neptune follows an elliptical path around the Sun, varying its distance to the Sun at different points along this. So see, this is the orbit of Neptune. Hope you can see the arrows. This is the just after this Pluto's orbit, you can see here. This is Neptune's orbit. And the year on Neptune is 60,190 days, or you can say 164.79 years. So now let's talk about Neptune's moons and rings. Neptune's moons. Neptune has at least 14 moons now discovered. Maybe more than that will be discovering. So the discovery date of Triton, one of the largest moon. This is the largest moon of the planet Neptune. And discovery date is 1846. And discoverer is William Lassell. And the diameter of Triton is 2,707 kilometers. with orbit length of 5 days and 21 hours. The largest moon is of planet Neptune is Triton. Please remember all this. This could be coming in your exams. So just mark all these kind of questions. And then there is Nereid, which was discovered by Gerard Kuiper. Maybe you have heard about the Kuiper belt, right? We studied about it. And there is Naiad, Thalassa, Despina, Galata, Larissa, Proteus. These all are Neptune's moons. These are the other moons of Neptune. Halimede, Tamate, Sao, Laomedia, and Nestor. Now, about Neptune's rings. There are a number of rings, right? And some of them are 50 kilometers, some of them we don't have data about. Now, let's talk about the exploration on Neptune. Of course, it could be Voyager 2, right? Voyager 2 spacecraft is a 722 kilogram space probe launched by NASA on August 20, 1977 to study the outer solar system and eventually interstellar space. It was actually launched before Voyager 1, but Voyager 1 moved faster and eventually passed it. It has been operating for 35 years, 6 months and 16 days as of here. Now it has been, of course, increased. Now, Voyager 2 is a part of Voyager program with its identical sister craft Voyager 1 and its extended mission tasked with locating and studying the boundaries.
Ma'am, by interstellar space, is Voyager trying to study like outside the solar system?
Why can't it study the outside solar system?
Because there's like another wood cloud on the way, and like the satellite gets hit by something.
So it just like when we go to the road, there is a chance of getting problems, right? If you go to the school, you can have problems, but that doesn't mean that we shouldn't go, right? That's the nature of human. That is, we always crave for exploration, and this is a good part of it. And again, I'm telling you, please ask your question after the session.
Okay.
So Voyager 2 is a part of Voyager program with its identical sister craft Voyager 1 and is an extended mission tasked with locating and studying the boundaries of solar system, including Kuiper belt, heliosphere, interstellar space, etc.
Ma'am, when it was launched?
Voyager 2 was launched in
1977.
This is our slide regarding Neptune. Now let's move to the coming slide. So now it's about the moon, our planet's largest natural satellite, the moon. It is the easiest astronomical object to observe. And it's the only scientific instrument you need is your eyes. So moon rotates on its own axis and moon revolves around Earth. And along with Earth, it revolves around the sun too. Moon has an axis tilt of, when you, with respect to the, Earth's equatorward region or ecliptic, it is 5.15 degrees. Now it rotates. Most important and curious thing about moon is moon's rotation period and revolution period are almost same. It is 27.3 days to complete one revolution, but 29.5 days to change from new moon to new moon. Okay. So why do we never see the dark side of moon? So there is a synchronous rotation, which is the reason why we never see the dark side of the moon. Over the millennia, the moon has been locked into a special kind of motion around the earth, and it rotates on its axis at the same pace as it revolves around the earth. And as a result, the moon keeps the same face towards us throughout its orbit. So this is it. Different phases are there. Sometimes it is full moon. Full moon means we can see the whole moon lit, and new moon day we don't see the moon. And in between there are different phases that we call it moon's phases. So this is new moon. It occurs when, consider this. This is sunlight, and this is earth. So moon is between sun and earth. That's why we see, the sunlight is, fall on the opposite side of the moon. That's why we don't see moon. And in full moon, it occurs when moon and the sun are in opposite sides of the earth. So this is sun and this is moon. So we see the whole moon, whole disk of the moon. So we see the full moon. Yeah, there are different names for full moon, funny names like moon after Yule, snow moon, sap moon. Yeah, all these means a full moon, but different names because different months. Now there is this thing called blue moon. Blue moon means, it's the funny picture is given here in blue color, but nothing like that. We see the normal moon, but it happens when there is more than one full moon in a month. When there is more than one full moon, usually in a month we see only one moon. But when there are two moons in a month or more than one moon in a month, we call it blue moon. That's it comes some every 2 years. That's why we say the phrase once in a blue moon means it is very rarely or very seldom, etc. And these are different phases. This is the first quarter. We see only half part of it. It's between new moon and full moon. And there is third quarter, one half when it is between full moon and new moon. So there are two phases which we can consider this. The first one is waxing. When the moon is between new moon and full moon, you can see here. Here we can't see the moon at all. That is new moon. To full moon, one phase is there, right? And that's called waxing. And when it is from full moon to new moon, we call it waning. Okay, waxing means slowly we can see the moon, and at last we can see full moon. And waning means slowly the moon will disappear, and at last we'll see no moon at all, the new moon. Yes. So there is another thing called crescent moon. This is very important. Please note it. So when the moon is between new moon and first quarter, that is new moon is here, and first quarter. When the moon is between new moon and first quarter, we call it waxing crescent. And when the moon is between third moon, okay, third quarter and new moon, it's called waning crescent. So here we have waxing crescent here between first quarter and new moon, and between third quarter and new moon we have waning crescent. Okay, waxing crescent and waning crescent. Now there is gibbous moon. Please make sure, please note this. Questions like this can come in the question. So if I ask, what is waxing crescent? You should answer when the moon is between new moon and first quarter. Okay. And then there is gibbous moon. So in the case of gibbous moon, see, when the moon is between first quarter, this is first quarter. Yeah, this is first quarter and this is full moon. When it is between first quarter and full moon, it's called waning gibbous. And when it is between full moon and waxing gibbous, and when it is between full moon, it is called waning gibbous. This is waxing gibbous and it is waning gibbous. Anyway, so this is the moon movie from new moon So waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, last quarter, waning crescent. You have to remember this, okay? This order. Yes. So this is the moon slide. Yeah, we have come to an end of it. Yes, if you have any doubts, you can ask. Already one more question. What? Yes.
Ma'am, like you said that the dark part is not visible, so is that the south pole of the moon?
No, it's not the pole. An entire moon's disk is, we cannot see. The polar region are in the up and down side, right?
Oh, yes.
That side is called the far side.
Excuse me, ma'am.
Yeah.
Ma'am, can you tell the distance from Sun to Neptune in astronomical units?
Okay.
And can you tell the value of one astronomical unit?
Okay. So sun to it's 30 astronomical units.
Yes, ma'am. And what is the value of one astronomical?
Oh, one astronomical unit. One astronomical unit is actually 1.49 into 10 raised to 7 kilometers.
Okay.
Yes. So there is one more question. What is uh, maybe you have heard about super moon, right? Sometimes since moon is revolving around the Earth in an elliptical orbit, so sometimes it comes closer to the Earth, right? And if it is coming closer to the Earth in a full moon day, we call it super moon because it is bigger than usual.
Ma'am, why sometimes the moon appears red?
Okay, why sometimes moon appears moon in red color. Now, if the moon is near to the horizon of Earth, okay, the light reflects to the Earth has to pass, just like sun appears reddish when it is rising or setting. Why is that? Because that blue color actually, or blue color scatters fastly, right? Like it scatters more. And what is remaining is red color. But when it is in the horizon, when sun or moon, whether it is in the horizon, it takes longer time. The rays has to travel longer time to reach the Earth. So that time already the blue wavelengths will be already scattered off, and what remaining will be red orange. That's why we see it that way.
Ma'am, and what you said, blue moon, how can it occur two times in a month? Like?
Yeah, sometimes it can occur 2 times in a month. Maybe it happens in 27, 29 days, right? There is 30, 31 days in a month, so it can happen sometimes. Maybe in the first in the first date of the month, if it happens, maybe in the 30th date of the month, it can happen. But it is very rare.
Yes, ma'am.
Yes.
How are tides, like how do tides occur due to moon's gravity?
Okay. Since there is gravitational force between Earth and Moon attracts. This ocean is a liquid form, right? So since because of that, since it is in liquid form, sometimes when it is um, coming, for example, if it is in front of the Pacific Ocean, what will happen? Of course, due to attraction, the sea level can rise and fall, and it also occurs between because it is revolving around Earth, and it is the closest celestial body of Earth. Okay, so due to the gravitational force, the thing is the gravity pulls the ocean towards the moon. Yes.
Excuse ma'am.
Yes.
Ma'am, can you explain tidal locking?
Tidal locking. Okay. Tidal locking between two. It's actually not. If you're asking tidal locking between Earth and the moon, right?
Yes, ma'am.
So it's a phenomenon which a body has the same rotational period as its orbit about period around a partner. For example, moon. So moon is tidally locked to the earth because it rotates in exactly the same time as it takes to orbit the earth.
Okay, ma'am.
Yes. So I wish you all the luck for your exams, okay, and also your future ventures. And I hopefully see all of you in the intermediate classes.
Okay, miss. Thank you.
Yeah, okay, thank you. Thank you all.